Very awkward. All right, homework 85 to 90. And somebody should help me remember to pass out papers. At the end of class. Yeah, at the end of class. So, here's the thing, guys. I told you day after day after day, and it's partly my fault for continuing to extend it. I should have just dropped stuff in. But but I had it on the board. I announced it day after day after day. If you have a missing in math, it means you're missing one or both of those homeworks that were collected a couple weeks ago. I will be collecting homeworks randomly from this week, and we will continue to have grades probably till the last week of school. Your final is next week, still being written, but as we talked about yesterday, you should at this point know all the things on the final. The Chapter 8 stuff that we're continuing to do, there won't really be much of that on the final. Might be a couple questions from it, but it'll be so fresh in your brain, it'll be okay. So, when we talk about construction, right, this lesson says constructing shapes. What do we need? What do you need for construction? Materials, okay. You know what you're working with. Measurements, like details, right? Yeah, what you're building, what your, so directions for what your end thing should look like. Tools to do the building, to make it happen. Earlier people said blueprints. Thinking about everything that blueprints have on them. Measurements, angles, degrees, elevations. Have you ever heard about an elevation? That's in reference to how high or low something is. So you would know that the first floor is going to be this far off of that point. So I want to give you guys a challenge. And we today are going to use, some confusion. So not this paper that was hidden under the Kleenex box, which I think you're the only person who grabbed this one. Not this paper. This is for the other math class. Sorry, Patrick. You still love you. Anyway, you're trying to break the rules. Oops. So, we are tracing with these papers. If you cannot see through your math journal paper, I have graph paper that is fairly thin. You can trace through it. So, when it says make one angle that measures 60 degrees on one side that is 1.5 centimeters long, my advice is always to make the side first. If you're given a length, do the length first. Because if you just try to make a 60-degree angle, you need lines, right? To make an angle, you need lines. So you might as well make the line that you want and then make the angle that you want. So go ahead, make a triangle with one 1.5 centimeter long side and one 60-degree angle. And that's all the info we have. Anybody absolutely can't see through your paper to trace? Also, I don't want to use this because it's expensive. Tracing paper is really pricey, actually. So I would say try the graph paper first. Anybody else need to try to get some thin paper? One 1.5 centimeter and one 60-degree angle. One 1.5 centimeter and one 60-degree angle. So first, I would make my 1.5. So the dots should make that kind of easier to see. I'm going to pull up my document camera to help you guys with this. So, and it's pretty small. Like on my graph paper, it only takes 2 boxes to do 1.5. So it's going to be pretty small. So can see how long it takes some people to notice.
What's that flashing light? Oh my god.
It's a party.
Oh. So you go get it. Is that fidget spinner? Yeah.
All right, so 1.5. For me, takes up that much space. It's very small. Then to do the 60-degree angle, this is going to be the base of the angle. Then I'm either going to point the angle up this way or up that way. I find it easiest to use the left point. So I'm going to take my 60 degree, turn it so that this end point is going to line up to this point. The line of my 1.5 will go with that line of the angle. So you can't really see through because of the camera, but now I have everything lined up. You can kind of see through my paper, I guess. This, I just lightly sketch up that line because I'm not sure how long it's going to be right now. Label your angle inside of the angle with 60 degrees. Everybody with me? Yeah.
Do we have another resource page? If you have another one.
I can print another. I think I'm out.
I can put this in a copy.
It's just as quick for me to print one. And the copy machine thing wastes. This is the wrong window. Print. Alright, black and white printers. Thank you very much. Finish your triangle. Finish your triangle. Right? They said triangle. We know it's a triangle. Do I don't know, try to make it look nice and try to like connect to here? Is that the right way to finish it? Is it wrong? I mean, I only stopped here because I hit the edge of my paper.
I know that because it's not any 30 degree.
Yeah, this angle is my 60 degree, right? Did I know anything about this angle or this angle? No. Nobody told me anything about it. So wait, could I finish my triangle like that?
Yeah.
Could I finish my triangle like that?
Yeah.
Could I finish my triangle and make it a right triangle like that? Crap. So wait, if all of these, according to you guys, are acceptable, and even this, and even this, and even that, what's wrong with this situation? Grant? Grant says we need to know two of our sides, and then we'd be able to figure this out. So let's try another one, see how this one goes. Let's try. So by the way, the point of that is for us to realize that we don't have enough information.
Was that unintended?
No, but sure. So this, I would make just some kind of sketch in your notes that, like, we don't know what's right. And when you finish the shape, that's called close. So we don't know how to close. We don't know how to finish our shape. We got a bunch of options. Actually, if I hadn't ran out of page, I could have had even more options. I could have had options where this third side goes out. So now I believe we have a quadrilateral next. Yeah, so with your sheet, because everything that you need today is on the sheet and traceable, make one angle of 30 degrees, one angle of 60 degrees, and one side that is 5 centimeters long. Now, I'll tell you, if you're anything like me and you're going to draw your triangles like going up, one strategy I like to use, and again, I would advise doing the 5 centimeter first, do your side first. I either leave space up here and draw down here, or I turn my paper. So I turn my paper, I can do my 5 centimeter right over here. I don't know if you guys can see anything. Make sure you label as you construct. There's no point in doing something specifically if we don't construct. So my first thing I would draw is my 5 centimeter line. Then we want to put a 60-degree angle on the one side, a 30-degree angle on the other side. And these resource pages, you guys can keep or do whatever with, so I do not do them all.
Oh.
Shouldn't see eyeballs looking back at me unless people are done. What's up? So once we have this 5, if you need help, you can go ahead and look up here. I like to work bigger angles down to smaller angles. So I need a 60-degree angle. So I'm going to set that up to go with the side that I have. So I'm going to make one of these edges kind of flat. And I'm going to line up my end point with the vertex of the angle. Check it. I'm just going to lightly sketch this. Make a happy tree. Make sure you label your angle 60 degrees. Because the sun is shining. But there's a slight breeze. Now, I have a question though. Where does this side stop? Onward! So I just keep going?
Yeah. Wait, doesn't the other side have to keep on going though? Right? Or no? No.
What other information do I have? I have a 30-degree angle. So, you guys are going to miss some important information. We don't necessarily know how long this side's supposed to be. But the other piece of information I do know for sure is I need a 30-degree angle. Can I place an angle if I don't know where my endpoint is?
No.
Not really. And if I try to, what's to say that it actually hits this point? Can I place an angle here and hope that it will hit my other side?
Yeah.
Yes. So place your 30-degree angle on this right side point. So I'm going to have to turn my resource page. I'm going to turn it that way, so my 30-degree. Then I can line up on your vertex, try to be straight. And then I sketch this. However, the whole sketch lightly because we don't know where it's going to end thing, that doesn't really apply here. Because I know where it's going to end. It's going to end where it ends, where it hits the other side. So because I knew that I had to have a 60-degree and a 30-degree, this ends up forming, actually, Alex, is this why you have your hand up? What is it? Well, yeah, but it's more specifically, it's a right triangle. And then I can darken this up, and I can erase my extra that is unnecessary. Any questions on that one? So these three things are... So wait, Grant had said we needed to know two sides and then one angle would be okay. So what about instead of two sides, we have one side and two angles? Would we all get the same triangle here? should. Wait a minute. Shoot. Say it louder. Quadrilateral. Crap. 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 Guys, we didn't make a quadrilateral, we made a triangle.
Well,
Does this side need to be how long we made it? No. Does this side need to be how long we made it? I have a solution. This corner loses today, and he's gone. And now, I win.
That's horrible.
We made a quadrilateral.
Oh, I see it. It looks like a shoe almost.
There once was, I forget how that goes. No, there was a lady who lived in the shoe. So, guys, be careful. And I know this lesson was a lot of like do your thing on your own, and some of you aren't doing your thing on your own, and you're just like carrying on a conversation of who's dating who, and oh my gosh, it really doesn't matter. So, be careful that when you have a list of directions, you're paying attention to the many directions that we have. I was so focused on 65 and 30 that I just got caught up and did a triangle. I needed a quadrilateral, but I didn't know anything about this side, or that side, so I can do whatever I want. Now here's the danger though. What if I had instead continued up this way imagine with me that that's, looks good. And then put the 30-degree off of this side. Where'd my 30 go? There's my 30. So I got to make an endpoint, right? I could make an endpoint like way up here.
Okay.
I mean, do I still have a 60-degree angle?
Yeah.
Right, 60-degree angle, my 5-centimeter line. And then from there, if I make a 30, so that goes somewhere, right? And then this will connect somewhere. Does this side have to be there? Does that 30 have to be there anymore? No, I put my 30 here. So why can't I just connect out to here?
Oh. Oh my gosh.
Or, now that still looks like a trapezoid, right? This edge, this edge, this edge, and this edge. Now these are all going to, well, not all going to be trapezoids, but I could also connect to there, or connect up to there, or connect up to there. So, again, do I have enough information? No, we don't have enough information. Because this is, now, if this had been a triangle, sweet, great, awesome, we'd all have the same triangle. But because it's quadrilateral, this is dangerous. Let's try another one.
If he turns the paper over, those lines he made are tracked.
By the way, in Desmos, if you want to go play with it, there are tools that you can do this online. So, I have a challenge for you guys. Can you write a list of directions that will get a partner or somebody the exact shape you're thinking?
Yeah.
So, hold up. I want you to first, now if your partner's really close to you, you're going to need to trade with somebody else here in a minute. I want you to first draw whatever shape you want. Triangle. We'll start with triangles because it's going to be the easiest, then we'll try quadrilaterals after that. Draw whatever kind of triangle you want using pieces from this paper. Right? So you can do like a 10-leg, a 5-leg, whatever. But Then, separate from that, so it can't be on the same page, easy to see, like you could fold it or you could like put one on the back, whatever. Write a list of directions that you think would get somebody else to draw the exact same triangle. Okay, so first draw what you want so you know what you're actually shooting for. Label all the important parts, and then write a list of directions. We want to see if anyone's good enough. Nobody this morning, at least I don't think anybody this morning, was actually successful with enough direction. I was always able to find a flaw in like, well, what if I do this? And, oh, that's a different shape. Hey, because I'm teaching all afternoon, I'm going to run and grab some water really quick. I'll be right back. So I just drank through this quicker than I thought. Alrighty then. And we can try this whole class. Do you guys want to do individual trading, or do you want to, like, if somebody's confident, you want to try to do theirs?
We'll do whole class.
So that's, I'm going to give you a couple more minutes. But so let's get to a point where if you are confident in your directions, we'll let you share it to the class and see if everybody makes the shape that you were thinking of. So another minute or two to write out your directions. Now the other thing, and I didn't want to say this at first, you're trying to be as efficient as possible. You don't want to waste words. So if you could use 3 steps in your directions instead of 4, you'd rather only have 3 steps in your directions. Because mathematicians are efficient. You okay? I was about to say, you're confident. 3 words in, I am not. Let's try this. Kate's confident. Something's got in my eye. That's not good. Alright, try this while I dig this out of my eye. Now, I will tell you how mathematically we would present these steps. Base length of 7 centimeters. I really don't want to ask you, but I keep like looking at these things if you guys are having your own like little social party or something over there. Base line or base length, 7 centimeters. Then what we would call this is base angles, because they're angles on the base, like on the bottom of the triangle. So she could say base angles of 15 degrees and 135. And then the saying it can go on until it connects isn't really necessary, actually. Try this out on your paper. I'll try it up here. 7 centimeter at the bottom. Base angles of 15 to 135. This graphic is really weird, man. Make sure you label the important things. Now, she said 15 on the left, so we're all following hers. Make sure you do your 15 on the left side. And 135. Make an obtuse triangle. I can barely fit 15 down in here. Kate, is this looking like what you had? Well, I know, but you guys are so quick. That arrow means I will extend it. Let's see if we got it right. There. Anyone else confident in their directions? No. Oh, you don't have the other triangle in here.
It's right here.
Okay, good. No, you're good. Just making sure. So ignore these shapes. They're extraneous. Draw a triangle with a side that's 5 centimeters, a side that's 3 centimeters, and a 45-degree angle. I'm trying to think if I can make that fall apart. So there's only one way for this to work, I think. I think you got it. We have 2 sides and the one angle. I'm not 100% sure. Try it out on your paper. I want to see if we all come up with the same thing. This is not right or wrong. This is testing were the directions clear enough. I'm going to draw mine off screen so we can just try it like real here. 5 centimeters. built me a broken triangle, Ella. I think we should all be very mad at Ella.
You brought yourself a turn.
It doesn't work. I didn't know what to do here, so I just went rogue and I did my own thing. I don't even know what that is. Because you didn't tell me. You just said do a 5, do a 3, and then do a 45. And this, if I keep going, is not going to connect. And it's very, very sad because he wants to make connections.
Aww.
He's an agent.
So, what did you need to set? Base angle of 45. So then if I connect that 3 with the base angle, that's going to be very much different. So I'm going to flip this, work on the other side of that 5. So I do that 5, and then I do, what was it, 45 degree? 45 degree off this. So then I got to make sure that it's 3. Now, is this my 3? The one that makes the 45 degree angle, or should my other one be 3? Like what I'm saying is, should my 3 come from over here, and then I just like make it work, or is this my 3? This is? Okay, so you didn't say that in your directions.
Sorry.
What do you think the point of my lesson is? Like, even when you think your directions are good enough. Yeah, that, and there are so many different manipulations. So this, then do we know what this angle is? Can you like tell me specifically what angle I need here, or do I just have to connect them? We just have to connect them. So that then does whatever it wants. This is a 5. That's a 3. This angle looks obtuse, but I'm not sure exactly what it is. I'm not sure exactly what this angle is. We're not sure what this is. We don't know a lot of things because we didn't have great details. Let's see what else we needed to cover. I don't think you can do this with a quadrilateral. Or anyone have another triangle they want to share? You think you've actually beat the code? Like, you think you actually got it? Because Ella's didn't have enough detail.
I don't know.
You think maybe?
Maybe.
Maybe?
I'm not entirely sure. Sort of see the shape through the.
Sort of. I think you got angry at this thing. Draw a triangle with 10 centimeter as base. 175 degree angle and 160 degree angle. 75 on left, 60 on right. So base angles are 75 and 60, right? So now we have, again, 2 angles and a side. And what I keep seeing is you guys keep putting the side between the angles. Like that's what Kate did. Right? She gave the side and the angles that came off of that side. Ella didn't, and then we got goofed up. But I think this works when you have the base given and the 2 angles given. Because if I do the base of 10 centimeters, so base of 10 centimeters. Try this out, guys. And then you say 75 and 60. Make sure you line up your vertex with the vertex or the point, your endpoint. .75, and we don't know how far that's going to go, so I'm just going to leave it with an arrow. On my other side, he told me to do the 60. So I'm going to set this kind of like that so I can line it up. So that's all the details. Gravity. This is all the details, except I just haven't extended my sides. So if I extend, ooh, a little bit longer. Now, see if this is the same as what Patrick had. I think you ran out of page space, didn't you?
I did, yeah.
Yeah, so mine looks slightly bigger because he ran out of page space and tried to cram it in. Maybe we should get a real big triangle there. Any questions about constructing? So we will go more formally over how we know we can only make one shape and how we know we could make multiple different representations. We have a couple minutes left. But the biggest thing about construction is check where your angles are supposed to be located. Check if things have to connect in a certain manner. And sometimes when you have instructions for a construction, it could potentially not work. Like all because you say do this, do that, doesn't mean it's going to form a triangle. It doesn't mean it's going to form the shape that you want. Or it doesn't mean that it's going to look the way that you were necessarily thinking. So we have like 2 or 3 minutes. I would start your homework. You probably had a couple questions done if you have your book open. / I will just bump these slides to that. Now you don't have to use a protractor for this. This is draw angles that approximate each of the following measures. You don't have to use it. So, like, what degrees is this sort of angle? 90, right? So if I half it, so that's not a very good half, but if I half it, how many degrees is that? 45. So we could estimate a 50 based off the 45. It's real close. The 170, what's that real close to? 180. 180 would be straight line, right? So 170, kink. A little bit of kink up. 170 as opposed to the straight line 180. Angry monkey. That was what I envisioned for using it.